We're going to talk about crystalline solids and the different structures that they can have. Crystalline structures, crystalline solids differ from amorphous solids because their ions, atoms, or molecules are arranged in a regular repeating pattern. This can lead to some beautiful substances. Natural crystals, snowflakes, are all due to the crystalline nature of these solids. The structure of the crystalline solid can be determined by X-ray crystallography. And this makes use of the concept of interference between waves. So as we learned earlier, electromagnetic waves can interact with each other and cause interference. We can have constructive interference where the waves add together and the amplitude becomes larger, or we can have destructive interference where the waves are out of phase. The trough of one lines up with the peak of another, and they cancel each other out. When we have light passing through two slits that are similar in distance to the wavelength, we get an interference pattern. And we talked about this when we talked about the wave-particle nature of electrons and of light. So atoms within the crystal have spacings on the order of 100 picometers. And that corresponds to the wavelength of X-rays. And so X-rays are useful in determining the structure of crystals. When you shine X-rays through the crystal, you get a diffraction pattern formed. The atoms and the spaces between them act as slits, and so we get diffraction patterns. And the diffraction pattern that we see reveals the spacing between the planes of the atoms. So if we look at this, two layers or planes of atoms on the surface of a crystal, if we have two different beams coming in, ray 1 and ray 2, they come in phase with each other, but one hits this atom and bounces off. This one goes through the first layer and hits the second layer and bounces off. And through geometry, we can determine the angle, you can determine the spacing between these based on the angle at which you get constructive and destructive interference. And I'm not going to go through all the geometry of that because I know that a lot of you aren't interested in that. If you are, this is the steps through here. The bottom line for this is Bragg's law, where an integer times the wavelength equals 2d sine of theta. And so theta here is the angle. N lambda is the difference in the path length when ray 1 hits and ray 2 hits. So typically the angle that produces constructive interference is measured. So they'll vary the angle at which these X-rays are shining on the solid, and they'll find the angle at which you get the brightest light. So the most constructive interference. You measure the angle, and then you can calculate the distance between the atomic layers, which is d. So some number n, that's an integer, times the wavelength. You know this because you know the wavelength of the X-rays that you're shining on them, divided by 2 sine of theta, and theta is the angle that you're measuring. And so this is how they determine the spacing between the two layers. And so that can be used to find simple atomic lattices. It's used to determine the structure of proteins. This was very important in understanding the structure of DNA. And it's also used for other biologically important molecules. So what do you need to know about this? You need to know how to use Bragg's law. So a problem like this. The spacing between layers of molybdenum atoms is 157 picometers. Calculate the angle at which 154 picometer X-rays produce a maximum reflection for n equals 1. So let's just go back and look at Bragg's law. D equals n lambda over 2 sine of theta. So D equals n lambda 2 sine of theta. Let's see. It doesn't really matter. This might be more convenient to use, but it doesn't really matter. We'll just go with this one. So here we're given the spacing between the layers, 157 picometers. What letter does that correspond to in this equation? The distance between the two layers. It's D. D for distance. So D equals 157 picometers. 154 picometer X-rays. What's this 154 picometers? What does this represent in the equation? We know D, and we're trying to find theta. So 154 picometers is what variable in the equation? Lambda. It's the wavelength of the X-rays. So lambda equals 154. And then we're told that n equals 1. So we need to rearrange this equation. So the sine of theta will equal n lambda over 2d. So we can plug these numbers in. N equals 1. Lambda is 154 picometers. And 2 times the distance, which is 157 picometers. We need to think about units. But the units don't have to be anything specific as long as the units of lambda and d are the same. So picometers are going to cancel out. So we get 154 divided by 2 divided by 157. So this is 0.49045. Is that the answer? No, we're looking for theta. Sine of theta is 0.49. Sine is a function, and to get rid of it, we need to do the opposite. So the opposite of sine is inverse sine. Let me find that in my calculator. So I want sine to the minus 1 is how my calculator gives inverse sine of 0.49045. And that tells me that theta, so on my calculator I'm doing this. So theta equals 29.37 degrees. It's an angle. Question? Would it be 3 significant figures? That is a good question. When we're mixing in sine, sig figs don't work so well. So off the top of my head, I really can't tell you exactly how many sig figs. 3 would be a great guess. We won't try to trick you with sig figs. and sine, definitely. I think it's better to write down too many than not enough. So, not a great answer, but that's my answer. Any other questions?